Hello everyone, welcome to our daily physics problem, day number 42. Today we have a disk of radius r and mass m slides down the incline. What is the acceleration of center of mass when it's down the incline? The moment inertia of the disk is 1/2 mr squared. So, I want you to pause the video, try it on. If you try, come back to the video, and then we will solve it together. So, welcome back guys. So first, let's approach it using the energy method. So we know the total energy, mechanical energy conserved. So mgh, the gravitational potential energy, have to transfer completely into the kinetic energy and the angular energy. Then we know the angular velocity is equal to and the velocity is equal to angular velocity times r. And I, the moment inertia, is equal to 1/2 mr squared. So we can plug them into the equation. We have mgh is equal to 1/2 mv squared plus 1/2 times 1/2 mr squared times omega squared, which is just v squared. Then we can cancel out m. We have gh will be equal to 3/4 times v squared. Then we can solve for v. V is equal to 4/3 times gh, and then all of them over square root. So now we can use our kinematic formula. We know that the final velocity squared is equal to the initial velocity, which is 0, plus 2ax. A is acceleration of the center of mass. Then we'll plug it in. It's 4 divided by 3 times gh is equal to 2ax. X is the displacement, and from here in the geometry of the triangle, we know x equal to h divided by sine theta. Then we plug it in. We can cancel out the h, sine theta, cancel out the h. So we have 4 divided by 3g times sine theta divided by 2, which is 4 divided by 6g times sine theta, will be equal to a. The a will be equal to 2 divided by 3 times g times sine theta. And that's our final solution. Thank you for watching.